All right, this is lesson 5.3. We are doing some division practice with two-digit divisors again. All you will need is a blue for this. I'm using a blue colored pencil. You could use a crayon if you'd like, but make sure it's a crayon or colored pencil. Go ahead and set up your journal to look like this. You need to have all 5 of the steps written, and then you can push pause on the video and resume it once your journal looks like mine. Okay. So the 5 steps to doing working with division with two-digit divisors are: step 1, find a benchmark number for the divisor. Remember, that's a number that ends in 0. That's close to the actual number. Step 2, you're going to do a guess and check, which means you're going to use your mental math skills and your multiplication skills to guess and find a close answer. Then you're going to use the real divisor for multiplication. And step 4, you're going to do the normal division steps, which are divide, multiply, subtract, bring down. Say those with me again. Divide, multiply, subtract, bring down. I really want to hear you whispering it. Let's do it again. Divide, multiply, subtract, bring down. Okay, and step number 5 is you're going to deal with the remainders. So you'll have to look at the problem to see what it's asking and what you need to do with the remainders. Because sometimes you get to leave it as a whole number, like the 4th grade way. Remember the little r with a number. Sometimes you need to put it into a fraction, which Ms. Fisher has taught you in 5th grade. Sometimes we're going to have to convert it to a decimal, and we don't know how to do that quite yet, but we will soon. Sometimes you completely ignore the remainder, and all they're looking for is the quotient. So again, I want you to remember that the quotient is separate from the remainder. The remainder is not part of the quotient. The quotient is its own thing, and the remainder is its own thing. So be thinking of that, okay? All right, so let's begin with a problem. Let's go ahead and do the, well, I want to kind of show you a cool way that we've done this. Let's just do a place value box method, okay? So draw your first place value box, and inside of it, I want you to write this number, 7276. The divisor is 34. 7276 divided by 34. Otherwise, that would be said as 7,276 divided by 34. If you look at it carefully, it looks like the standard algorithm, just with extra lines. So let me show you. See how if I get rid of those lines, it looks like just a normal division problem? That's because they're the same. It's just a different way to do this. So let's go ahead and go to the problem. So remember, step 1, find a benchmark number for the divisor. So you look at number 34 and you think to yourself, is 34 closest to 30 or closest to 40? We want a number that ends in 0. It's closer to 30. So let's write 30 in parentheses underneath it. I'm going to use blue for the parentheses. Now I'm going to do the guess and check, step number 2, which is guess and check. So I use the number 30 to count by 30s, and I see which number it's going to go into. Okay, it's going to go into more than 7, but you're going to stop here at the 72 because 34 won't go into 7. But it will go into 72, so that's where I stop, and that's where the first number is going to be, is above the 2. So I use the guess and check method, which is to take 30 and to list off multiples. So I always look at it and I go, well, how many times will 3 go into 7? I take the first numbers, or the first 2 numbers, or I just do multiples of 30. So 30, 60, 90. 90 would be way too high, but 60 would work, so that was 2 times, right? So now I'm on step number. So my guess and check is the light bulb moment. So let's see, where could we do the math down here? Will you draw a light bulb? Remember, that's the guess and check. I think it's going to be 2, but I would like to check. Okay, that's a light bulb moment where your brain is thinking, I think it's going to be 2, but I have to do the multiplication to make sure. So I try 2, and I'm on step number 3. I use the real divisor for this. The real divisor is not 30. That just helps me guess and check. The real divisor is 34. So I do 34 times 2. And you should get 68. So did 2 work? Is 68 smaller than 72? Yeah, so it is 2. So I put a 2 in my quotient line. But in this method, we add zeros for place values. Will you pick up your blue and let's practice that? Because 34 doesn't go into 7,000 only 2 times. It goes in 200 times. So we put zeros in the additional place values in the quotient. Now I do multiplication. What was 34 times 200? Well, I don't know what it is times 200, but I know 34 times 2 is 68. I'm going to continue to write with my blue to show this. And then you have the 2 zeros, right? Or you could say 34 times 200 is 6,800. Now, what do you do with those numbers? You subtract them. So put the subtraction sign with an equals bar and begin on the right with subtraction. You have some leftovers and you need to bring them into a new box. So bring 476 into a new place value box. And start the process all over again. So it's not going to go into 4, but it will go into 47. If you think about 34, we already know that times 2 is 68, so it can't even be 2, it just has to be 1. But it's actually 10, right? I should use my blue for that. It's actually 10. And what is 34 times 10? Well, it's 340, or it's 34 with a 0. And I subtract that to find out what my new leftovers are. $136 are my leftovers, so I bring it into a new place value box. And I start the process all over again. Remember, the divisor is still 34, but I use 30 as my guess and check. 34 is not going to go into 1, so I put an X above that, and it won't go into 13, so I put an X above that. So I'm looking for how many times it will go into exactly 136. And remember, there could be a remainder, so it doesn't have to be perfect, but you have to not have any leftovers or remainder that is 34 or more. It has to be smaller than that. So let's use our 30 to start guessing. We know it's got to be more than 2 because that was 68. So what would 30 times 3 be? 90. I think we could keep going. 30 times 4, 120. 30 times 5, 150. So that was too high. So my next light bulb moment is a 4. I'm going to guess and check the 4. Draw a light bulb and write 4. Take the original divisor, so not 30, but take 34 and times it by 4. Well, look at that. It is 4. So I put the 4 in the quotient line. I subtract 136 to prove that I have 0 leftovers or 0 remainder. And when I put all these place values together, 210 and 4, what would I get? I got a 2 in the hundreds place, a 1 in the tens place, and a 4 in the ones. Well, 200 plus 10 plus 4 is 214. 214. Now, really briefly, I want to teach you something that you probably learned in 4th grade, and I just want to make sure we know how to do it, okay? Because sometimes we can forget, especially when it's been a long time. How would I prove that my answer is correct? So we're going to write the word proof. P-R-O-O-F. My proof would be to take the quotient, which was 214, and to use the opposite operation. So the operation I used was division. What's the opposite of division? Multiplication. So I'm going to take 214, and I'm going to multiply it. Does anyone know what you multiply it by? Think about it. It's by the divisor. So it's by 34. Do you know what answer I should get if it's correct? You should get the dividend, the 7276 that you originally started with. So let's give that a try. You know how to do multiplication like this. We've learned it before this unit. So just go ahead and solve it. Make sure you use that 0 for place value. See if you got the same partial products as me. I did. I got the dividend, 7276. Okay, so again, we're going to write the word proof over here. How you prove something is you take the quotient multiplied by the divisor, and you should get the dividend. You're going to need to know how to do this, so don't think we were just doing it for fun. You might have to prove some things. So for proof, you take the quotient multiplied by the divisor, and it should give you the dividend. What's pretty cool is if you have a remainder, that proof changes a little bit. And I wonder if you know what to do with that. Think about that for a minute. Where would the remainder work into this proof if I had one? Let's say the remainder was 2. Have you learned that before? You take the quotient multiplied by the divisor, then whatever answer you get, you have to add the remainder to it. So it's one extra step if you have the remainder. So you do quotient times divisor equals x, and then you do plus the remainder to that x, and it gives you the dividend. It's pretty cool. Maybe we'll try one that has a remainder and see if we can work that out, work the proof out. Okay, so that is how you would do this. Look at all that work for one problem. Isn't that crazy? So crazy. There are so many different ways to do multiplication though, and you don't always have to do these place value sections. So let's go to using standard algorithm, and we're going to practice another one. So slide your journal down, and let's try another problem. Maybe I can try to find one with a remainder. Okay, let's try this one. Put it in standard division, so it looks like it's this box. It's not really a box, huh? I call it a division house. And the dividend is 4722. You don't need to put commas. But where would that comma go, do you know? If you said in between the 4 and 7, you're right. Okay, and the divisor is 57. So write the divisor to the left. You still have to follow these 5 steps when using standard division. You still have to find a benchmark number. You still have to do guess and check. You still have to use the real divisor. you still do normal division and you still deal with remainders. So it's the same steps, just a different way to do them. Pretty cool. Okay, so what is 57 really close to that we're going to put in parentheses? Ends in a 0. We're going to use it for our guess and check. It's called the benchmark number. It's 60. Okay, so is 57 or is 60, one of those, are they going to go into 4? No. So you put an X there. Is it going to go into 47? No. You put an X there. So we're already into the tens place values. This was thousands, hundreds, then tens. So it doesn't go above the 4. It doesn't go above the 7. It's going to go above that first 2. So I start thinking, okay, I look at the first 2 digits that I'm dealing with. So I'm looking at 472, but I just think about 47 for a minute. And then I think about 60. Sometimes I think about 6 into 47. That helps me sometimes too. 6 will go into 47 7 times because 6 times 7 is 42. 6 times 8 is 48. That's really close to this. What do you think? Should we try 8 or 7? Let's try 7. So where should I do light bulbs? Where should I do guess and check? Do I do it underneath here? No way. You need long spaces under there. You cannot do your guess and check under here. You can do it under if you're doing place value sections because you go left and right. But if you are using standard algorithm, you're working up and down, and so you can't do it underneath. You're going to have to do it to the side. So let's guess and check with, what did we say we were going to try? 7? Okay, we're going to try 7. So put a light bulb. We're going to try 7. Okay? What are we timesing by 7? The actual divisor, which was 57. I got 399. And I'm looking for 472. Do you think I could get 57 more? Let's pretend that I didn't think about that and I just put the answer 7. So will you please write the answer 7 above the first 2? Let's just say it's 7. And that's 399, so you start on the left. And this time you're doing digit by digit, so you just subtract that. Wow, I have 73. That means there was 73 between 399 and 472. So I actually could have got another group of 57. So actually this was too low. Too low. So it was 8. If you get a remainder here and it's bigger than the divisor without you even bringing down the number, you have a problem here. You have to start thinking about that kind of stuff. You can't just go super fast. You need to check yourself at every step. So it cannot be 7, so erase it. All that work gets erased. And I'm even going to have to rewrite my 472 up here because I did some borrowing and it makes it look real messy. So it needs to be one more, which means it has to be 8. That's much closer. So you put an 8 in your quotient line. And now subtract 456 and see if your remainder is less than 57. It needs to be, otherwise we have a problem. Whew. Thank goodness. Do you see that it's 16? Okay, so how do I continue this process? If you're doing just standard algorithm, you bring down the next number. You have to show the arrow. And now it's like having a whole new place value box. You just start over with 162. How many times will 57 go into 162? Well, we know it's less than 7 times because that was a really big number. I'm only looking for 162. So I'm looking for less than half of that. So it's got to be half of 7, which would be like 3 or 4 maybe. So go back to your guess and check method. You're 60. 60 into 162. Well, 60 times 3 is 180. 60 times 2 is 120. Should we try 2 or 3? If you think 2, you're probably thinking, well, but 180 was too high. But remember, the real number is 57. The real number is lower. So we could try 3. Well, let's just see what happens. So the light bulb moment here, off to the side, is 3. I'm going to try 3. So I take my original divisor and I try 3. Oh no, what just happened? It's too high. What do I do? It can't be 171. I only have 162. So it's got to be 2 times. So because it was too high, I am now trying it times 2. And that one worked. So it's 2 in my quotient line. And then I subtract 114 from 162. I cannot get a remainder that is more than 50. It can't be 57 or more. It has to be smaller than 57. $48. So it's 82, remainder 48. Because there's no more numbers to bring down. You circle that in blue as well. Will you write that as a 5th grader as well? I'm just going to write it over here. Remember that the numerator is 48 and the denominator is 57 because that's just how it works. The remainder is the numerator and the divisor is the denominator. And actually that can be simplified, but I'm not going to make you simplify it. That's pretty crazy, but they can both be divided by 3, I believe. And it makes 16/19, but I'm not going to make you do that. You can just leave it like that, okay? All right, so now how do we show proof for this kind of problem? How you show proof is the quotient times the divisor. Let's write those out in words. Equals, and then we'll just leave an empty bubble because whatever that answer equals is not your final proof. Then you have to add the remainder to get the dividend. There's a lot of things you have to do here to get your final answer in proof. Okay, so let's do all of that. So take the quotient. Remember, it's just 82. So I take 82 and I times it by the divisor, which was 57. This is going to be a double by double, or I'm going to have to use a 0 for place value. Go ahead and multiply that together and see if we get the same partial products. Did you get the same partial products as me? 574 and 4100. If you didn't, double check. And now what do I do with the 4,674? I add the remainder. My remainder was a fraction. Now you want to add the whole number remainder, which is 48. That's why I did the blue R. So add that together and see if you get the dividend. Check. This is proof. So that's just a little bit different because we had a remainder that time, right? So that's how you would prove your answer. Pretty exciting stuff. I will see you in the next video.